Okay, continuing on with the standard shader. Let me get a share screen going here. So in our material, here's an example of a material. We have the albedo. The albedo is the color of our material. The colors are altered by the lighting and whether it's shiny and so forth. But the albedo is kind of the base color of the surface. We can, in a material, if we were to make a material, here we've made a new material, I can specify its color from the color picker. So here I'm specifying, specifying the color. So my material is this straightforward kind of shiny thing. I can look at it in different lighting conditions and with different objects. I can turn the light on and off, and I can do various things with the reflection probe or other things. Let me get back to the sphere. So that's kind of my default material there, with nothing but a color on it. But more commonly, we have some kind of texture. So here are two textures that we might have. This would be for a complex character. And the details of how this is mapped onto the character is way beyond this class. But here's a kind of square one that is mapped more straightforwardly. If we are using a transparent material, we can specify its alpha channel. This is a measure of how transparent it is. We only see this if we're in transparent mode. So now the object is somewhat transparent. And so in the color picker, we can set its transparency through that fourth channel. There's the red, green, and blue channel, and the alpha channel, which is transparency. But that only has effect if we're in one of these transparent modes here. In opaque, it has no effect. Let me set this back to white. So we're going to have these different materials, or these different textures that we lay on our material in these different slots, and the albedo color is the base. With transparency, we can have regions that are semi-transparent and regions that are completely opaque by using by having the alpha channel contain this black and white. Black is fully transparent, white is fully opaque, and gray is somewhere in between. And this is in the alpha channel of my base material. Often we set that in some tool like Photoshop or GIMP. Here we're seeing the broken glass we can see clearly through, but the semi-transparent part has some opacity. I mentioned in the specular workflow that we had a specular parameter, and this is to make the shiny spots on a smooth material. Uh, Two different workflows, the metallic workflow of the standard shader and the specular workflow of the standard specular setup. In the metallic, we have something called a smoothness parameter that controls the clarity of that specular effect. So where's my little material that I just made here? Here's my material. If I crank up the metalness, it becomes shinier and looks more like metal. And if I crank up the smoothness, let me go back to the sphere for the smoothness. So here we have a fully metallic, completely smooth material, which means we're actually getting a reflection of the skybox in this case. As I crank down the smoothness, it becomes fuzzier. You can think of this as the surface getting rougher. If we go all the way to the end here of smooth, our specular highlights have disappeared and we have kind of a chalk-like material, even though it's metallic. The metallic means that the coloring is coming mainly from the skybox, whereas when I crank down here, the coloring is coming mainly from its albedo. Let me put something in the albedo here just so we can see it. So this is that stone texture that we're going to look at over here. If I make this metallic and make it very smooth, it becomes kind of very shiny. There's still the albedo color there, but it's quite shiny, quite metallic. In the specular workflow, here we have a specular highlight color that we can specify, make it yellow, and crank down the smoothness, and you see that the specular highlight there gets larger. As I go all the way to the end here, now the specular color is spread out over the material. Somewhere in about 0.5 is usually a good value, and I actually like the metallic workflow better anyway. Smoothness in here and a metallicness somewhere here. So there's our stone material. There's metallicness going from 0 to 1. The metallic and smoothness kind of work together. If you do put a texture in the metallic slot, it uses the red channel for the metallic level, and the smoothness level is used by the alpha channel, which means that the green and blue channels are both ignored. So I don't know what will happen here if I take this new material and I put that base color in for the metallicness. Then, well, I don't think my material has anything in the alpha channel anyway, so it doesn't do anything. Never mind. TMO, too many options. Play with it. The way one might use this is with a material, an object that you want to be metal in one place and rough, diffuse in another. Um, if we have only a single value, the whole thing has the same kind of shininess. Whereas over here, I have this kind of map that means that the buckle, the metal part of this thing is going to be shiny and the rest of it is kind of opaque or is kind of rough. So by using these different channels, we can make our material look different in different places. I'll show you examples of these later. A really interesting one is the normal map. Normal map is how bumpy the surface is. And this is a trick that is used in computer graphics to give the material, give the object more surface relief than is actually there in the polygons. So I think I'll use the example here. Right here, what we're looking at is just an albedo material. So it looks very flat. But if I move forward and apply a normal map to it, suddenly it has this kind of bumpy texture. And you see as the sunlight rotates around that the specular highlights, the shiny spots, move as though the surface were three-dimensional. And that's, of course, very cool. We can use this to make the appearance of bumps and rivets and grooves in what's otherwise a flat plane that has no structure to it, but we can give these the appearance of bumps. Lots of texture that's not really there in the model. Height map is a similar feature. This is sometimes called parallax mapping. And in this case, the normals that determine the lighting are adjusted based on whether it's leaning towards or leaning away from the camera. And so with height mapping, this is our normal material. And now with a height map, now the material is kind of distorted so that where it's leaning away from the character, it's kind of tilted up, and where it's leaning away, it's tilted down. And so this makes the material look like it's much bumpier than it actually is. This is a flat plane that we're walking on. It has no surface relief whatsoever. Examples of a height map, the white spaces are going to be pushed up, the black spaces are going to be pushed down, and so our height map is usually a grayscale image with white representing high and black representing low. And of course, there's a slider that lets you set how much of an effect this produces, so it's pretty cool. Occlusion mapping is it kind of lets you make the low areas darker. An occlusion map will is also a grayscale image. White indicate areas that get full indirect lighting. This is remember, indirect lighting, and black indicates no indirect lighting. And so with this feature implemented, we now have kind of much darker regions in here that are picking up less of the indirect light that's coming from our skybox here. And so the valleys tend to look darker and the hills tend to look higher. And frequently the occlusion map looks a lot like the height map. Here's an example where they've used it to make it darker in under the character's chin. We've seen emissive materials that give off light, And this is one of the slots in our material. Where's that material that we were playing with? That new material. Um, here I can check emission, and now I have a slot where I can drop either an emitted color, or I can use the color picker to emit color from this. Let me pull in one of my emissions here that I've got set up. So this is going to emit, and I believe I can give it a color. So I can give it kind of a yellowish color. And so this is now going to give the appearance of a glowing yellow material. Here's that HDR, high dynamic range. When we're playing with this color, we can step it up into a high dynamic range or step it down so that it's not so bright. So this is a way of kind of adjusting the intensity of our material. And of course, there's a mask so that one can make different parts of an object emit. So here's the emission mask, is just this area. And so on our object, most of it's going to be non-emitting material, but it has these little light lit panels on it. So very flexible in what you can do with this. Detail maps are an overlay of a second set of textures that you can overlay on top of the first one. And one thing I did in here is just that I took exactly the same texture that the same albedo texture, but I put it on with higher tiling. And so my detailed map has a higher tiling than the base map. And so I'm getting much more roughness in here. And of course, it doesn't have to be the same texture. Here's an example where I've overlaid a lace texture on my rocks. Not sure where in the universe you would see such a rock, but these rocks have this cutout lace texture. I've used the cutouts in this texture to make it so you can see through the lace texture into the rocks below. I think here's emission. This is glowing lava field that has an emissive texture, and I don't believe I'm bothering to light map this, so it's not actually contributing to the light map, although you couldn't make it contribute by baking it. The detail maps here, in this case, the character has freckles. This is what the detail map looks like. The detail map has both an albedo and a normal map, and you can set its tiling so that you can control kind of the size of those details. I mentioned way back that there's something called Fresnel Diffraction. I believe it's Fresnel. But this is basically that as you get to a grazing angle on something, it becomes shinier, and so you get these kind of, more reflection at a grazing angle than you do at a steeper angle. And this is included in the standard shader. Here's some reference charts for metallic settings, different things that look like. Now, one thing, where did all these different maps come from, the normal maps and the height maps? I believe I showed you a hack for making a normal map from an albedo texture. You make a copy of it and then import it as a normal map with create from grayscale checked. And this makes a serviceable normal map. It is by no means accurate, but it's good enough to make things look bumpy. Alternatively, there's software that will do that for you in a more controlled way. One of these is Crazy Bump, which used to be free. I'm not sure if it still is now, but I'll let you go look at that website and see if you can find anything that's interesting. Okay, I'm going to stop sharing there, and I'm going to stop recording, and I'll see you all in class. Bye.